Okay guys, part 2 of the solving with logs video. I decided to split it up into parts for each page. We'll just do one page per video. The first page was the easiest version. It was, when you have, when you have the same base, you just use the property of equality and get rid of the logs and just solve for the inputs. The other scenarios aren't as easy. This one is when you have multiple or more than 2 logs with the same base and leading coefficients. Okay. So in these problems, we're going to have to use the properties that we talked about the past couple days to condense the logs and then use the property of equality to solve. Okay. So in the first one, we have log base 3 of 7 plus log base 3 of x equals log base 3 of 21. Okay. The property of equality only works if there's one log on the left and one log on the right. So right now we have 2 logs on the left. So we're going to have to make it, condense it into 1 log. We're going to use the product property from yesterday or a couple days ago, which says if we have 2 logs with the same base and we're adding them together, we could just multiply their arguments. So this would become log base 3 of 7 times x equals log base 3 of 21. Now we use the property of equality, get rid of the log portion, and you're left with 7x equals 21. Okay. Linear equation, just solve for x. Divide by 7, divide by 7, so x equals 3. Okay. Take a second, make sure it doesn't make any of your logs in the original problem negative, and it's obviously not going to. So x equals 3 is our answer. Okay. Part B, B has 3 logs on the left. Again, we could only work if it only has 1 log. So we need to convert it into 1 log. Okay, so these are all log base 10s. You got log of 4 plus log of x minus log of 5. Again, plus is going to mean multiplication and minus is going to mean division. So this is from left to right, 4 times x divided by 5. And on the right side equals log 20. Okay. All right, now use the property of equality, get rid of the log portions, and just solve 4x over 5 equals 20. Okay. We do this in about 2 steps. Multiply both sides by 5 to get rid of the fraction. I'm going to leave you with 4x equals 100. And then divide both sides by 4. So x equals 25. Now you can check that work, especially with log base 10 in your calculator. You can do log of 4 plus log of 25 plus minus log of 5, and you should get log of 20 out, the same result of log of 20. All right, and then the last one in this scenario. This time we have 1 log on the left, but it has a number in front, and we have 2 logs on the right side. Okay. So the first thing on the left side we're going to have to do is we're going to have to move this 2 that's out front, and remember that that becomes the exponent. Okay. So the left side needs to be rewritten as log of x squared. The right side has 2 logs and we need it to have 1. So what we're going to do, since it's plus, we're going to multiply those 2 together. 4 times x minus 1. Okay. Your bases are the same. So only worry about the input part. X squared has to equal 4 times x minus 1. All right, now your first instinct here should be to distribute that 4, and you're right. So now we got x squared equals 4x minus 4. This is a quadratic, so we're going to have to move everything to one side to solve. So just like those ones in the first scenario, anytime you have a quadratic, we're going to have to move everything over. So subtract 4x on both sides, plus 4 on both sides. Goes away, that goes away. And we're going to be left with, let's go over here, x squared minus 4x plus 4 equals 0. Okay. Quadratic in standard form, got to factor that. What multiplies to positive 4 and adds to negative 4? That's going to be negative 2 and negative 2. It's a perfect square trinomial. Okay. So we had one like that in the first scenario where they're both the same, so we don't have to do it twice, so we're just going to have x minus 2 equals 0. And therefore x equals 2. Alright, so that's when you have same bases with your logs, but there's either multiple occurrences of them, or some of the logs have a number in front. Okay, so you want to condense it into one log with a 1 in front. And then again, whatever equation you're left with, solve it. If it's linear, solve for x. If it's quadratic, get everything on one side, factor, solve for x. Alright, that's part 2.